Hello, welcome. Mr. Shapleski here. I am about to go through lesson 1.4 with you on how to rewrite equations. Sometimes they're called literal equations, rewriting literal equations. Don't forget your title. And example 1 will be x plus y equals 4. So you're going to see, besides just the function you need, x plus y equals 4, you're also going to see some extra stuff that'll tell you what you're going to be getting alone. The words can be different sometimes, but this one says rearrange for y. That means that when you're done, you're going to have y all by itself alone on one side of the equal sign and a bunch of other stuff over here on the other side. So for this first problem here, x plus y equals 4, I'm going to compare this equation to something you might be a little bit more familiar with. If I had a problem like 2 plus y equals 4, and I asked you to solve, I bet many of you could tell me how to do that. For example, for this problem here, you would subtract 2 to both sides, and you'd end up with a value of y equals 2. 4 minus 2 is 2. The purpose for doing that, and the purpose for the subtraction, is because it is the opposite operation that you have here, which is a plus. So to undo a plus sign, because the 2 is also positive, you are going to subtract 2 from both sides. Now that's how you do it with numbers. You're probably familiar with that. But how do you do it when you have multiple letters like this? Sometimes you'll have 2 letters and a number. Sometimes you have 3, 4 letters, maybe a number. The way to do it is to get the y alone. So I like to look at this y and think of myself like anchoring it down. I'll put an arrow above it, so I anchor it down. That's the piece I don't want to move normally, because I want to end up with the y alone. I want to move everything else besides the y that's on that side of the equal sign. So I have this x here. So how do I get rid of the x? Well, the same way I would, because it's an addition in the other problem, I would subtract the x from this side. So x minus x goes away, cancels, it undoes each other, so that becomes 0, and the y is alone. And it's actually really simple. Some of these are one step, some of them are multiple steps. You end up with this, y equals, now you have a choice here. You can write 4 minus x, or if you want to put the x first, you could write the negative x first, but the 4 is positive, so it would be plus 4. Either one of these is acceptable. That's more likely the problem that you would have. That's the beginning problem. That's how you do it. Second question here, I've got 3x equals RT, and for this problem I'm going to ask to rearrange, and I'm going to say it in a different way. I'm going to solve for R. What that means is I want to get the R alone. So the R has to be all by itself and other stuff has to be on the other side. Doesn't matter if the R is on the left or if the R is on the right. So for this problem here, the R starts on the right, so I'm going to anchor it down and not move it, but I'm going to get rid of the thing that's with it. The thing that's with it is this t. Well, how do I get rid of the t? Well, you have to do an inverse operation. So because there's an implied multiplication here, the little dot, you would end up having to divide, because to get rid of multiply, you divide. So you're dividing both sides by t. You're going to end up with a result of r equals, oh no, I can't really do this, so I leave it as 3x over t. If you notice, you really don't do a lot of combining or adding to finish the problem. You just need to write it clearly. 3x over t is the same as r. Why do we want to do something like this? Well, sometimes it's easier to work with the functions in this form than it is to work in the original form. So it's helpful to try to rearrange these functions. Moving on to the next one. This is actually a function you might be familiar with. Distance equals rate times time, d equals rt. Very similar to the last one. Let's say on this one I'm going to solve for t, or rearrange for t. So I want to get t alone. So if you want to give it a try, pause the video, feel free. I'll give you the answer in a moment. And for this problem, because it's multiplication again, the time I'm going, whoops, I did that incorrectly. The time that I'm going to to work on here is going to be solved, and I'm going to get a result of T equals D over R. So that might be helpful if I need to find the time of an object, and I know how much it traveled, and I know how fast it traveled. The distance is how long it traveled. The R is the rate it travels at, the speed. So sometimes it's more helpful to have equations in this form. Most challenging one, so let me rewrite it a little larger here for you. It's the square root of t over x equals m plus g. And I'm going to say rearrange this for t. So I want t to be alone. So t's on the left side of the equal sign, and there are two things on the left side. Thing number one is a square root symbol. So when I'm looking at that, here I'm going to use my little, I found a new toy on my my iPad I'm doing these videos on. It's a lightsaber. So if you look right here, there is a square root on the side with the t, and there's also my x. Pretty neat lightsaber, huh? And it even makes noise. I don't know if you guys can hear that. Haha, isn't that cool? All right, anyways, I need to get the t alone. So there's two things I need to do. I need to get rid of the square root, and I need to get rid of the x. So if you remember, please excuse my dear Aunt Sally is the PEMDAS. It's the order of operations. Normally you go like this. However, when you solve equations, you don't go in that direction. You undo, so you go in this direction. So I've got two things happening here. I've got a division problem, and I've got this square root. Now the square root technically is it's kind of like forcing this to be a grouping together here. So I'm going to actually get rid of that square root first. Do you know how to get rid of a square root? Well, if you don't, you're going to learn right now. To get rid of a square root, to get rid of a square root, I'm going to square both sides, because squaring and square rooting undo each other. So that will then cancel this 2 with this square root. I'm just going to kind of cross it out. So what happens is I'm left with t over x, that's division, equals m plus g, and now this is squared. You can square things, but in this case I'm not going to square it. I'm just going to leave it because it's two letters and I can't combine them. So my question is, did I get t alone? The answer is no. I'm getting closer though. So it's two steps in this problem. So how do I get rid of divided by x? Well, the opposite of division is multiplication. So I'm going to multiply both sides by x. That'll cancel my x's, and then lo and behold, my t is alone. What's on the other side? All of this stuff. You don't have to simplify it. You just have to rewrite it. M plus g squared and then times x. You can put the x out front or you can put the x out back. It doesn't make any difference. That is how some simple examples of solving some literal equations for other letters. Unfortunately, I'm only doing 4 examples here, and probably I need to do like 20 for you to fully get the handle of this. So in class, we're going to do a bunch more, but this will at least get you started. Thanks for listening.